Might as well record the review. Cool. I'll share my screen. All right, folks, so we are talking about the chi-squared exercises. So the first thing I'm going to do is import pandas, scipy, and anything else that I might need. I'm going to end up using the iter tools on that little bonus that I gave you all. I gave that bonus to myself as well to produce chi-squared test for every pairing of categorical variable on a data set. This first exercise, we gave you raw numbers. So the way to turn raw numbers into a data frame is to make a data frame with labeling your indices. In this case, uses MacBook versus doesn't use a MacBook. And labeling your columns. All these are a list of strings, right? How do you know if something's a string? Well, it's in quotes. And anything that's not in quotes is either a variable or a part of the language. So we specify the index, the columns, and then we have our rows of data, okay? So I'm gonna crank out that data frame. The model for producing this work was in the curriculum on how to set this up. You basically copy it, paste it, and change the column names and the values, right? So eyeballing this right here, before we even run a test, it looks pretty likely that using a MacBook and being a CodeUp student do have some sort of relationship, right? You already know that there is a relationship, but let's answer the question programmatically. Let's set my alpha to 0.05. We can set it higher to be safe. And what I'm going to do here is once I have the observed data frame, so work with an array of arrays too. Once you have your observed values, your cross tabulation will call stats.chi-squared contingency on that observed data frame. This is going to give us back 4 values, and the order matters here. Order matters in programming, right? The chi-squared statistic value, which we don't need, the p-value, which we totally do, the degrees of freedom, and the expected values. So look at that. That p-value is way low, way low. And you bet your boots it's less than alpha. So we reject our null hypothesis, which begs the question, what in the heck is the null hypothesis? I need to write this down, right? The null hypothesis is that there's no dependence, or they are independent, or there's no dependence. Yeah, same thing, right? So that MacBook use and being a CodeUp student are independent of each other. And if that's our null hypothesis, our alternative hypothesis is that there is a relationship. The alternative hypothesis is that there is some relationship, or even dependence, we might say, between Mac use and being a CodeUp student or not, at least with this data. So we reject that null hypothesis quite soundly. 9 zeros, right? That's not too shabby. Questions about this first one, folks? Okay, let's move into exercise 2. Exercise 2 has us, oh, thank you. Oh, I didn't see that, Arsene. Go ahead.
Yeah, no problem. I was gonna turn on the audio. So I saw that you used you wrote chi-square, etc., and then chi squared contingency observed.
Yep.
So I just wrote because when I created the data frame, I used Mac CodeUp as the name of the data frame, and instead of writing observe, I wrote Mac CodeUp, but I still got like the observed number. So I wanted to know if it doesn't matter whether you use. Yes, exactly.
Yeah.
All right.
Fundamental property of variables, variables are a substitute for the value that they're pointing to. So if we say X is pointing to this data frame, then X is that data frame. And if later we say X is that data frame, it's totally that data frame.
Oh, did you use observed as the name of the data frame? I didn't
I
see
did.
it.
Yeah,
Oh.
I did.
Oh, okay. I didn't notice that. Okay. Okay.
Yeah,
Sorry.
and this data frame is a manual cross tabulation.
Yeah, I realized that a little bit later.
But you realized it. That's good. Any other thoughts, questions, comments? Okay, cool. Cool, we'll keep on going. Let's do number 2. I'll do the simple version first. I'm going to pull in the MPG data set. And to program defensively, because class is a reserved word, I'm going to rename the column called class. I'm going to call it vehicle type. Because class is reserved. And then because we're working with, our test is gonna, we might have to work on if something's automatic or not, right? I don't want to have to deal with auto L4, auto L5 versus manual L4, or whatever the other numbers are. So I'm going to make a nice little Boolean here that holds is automatic. We know that's the case if the transmission column starts with an A. We don't have a lot of fancy values in there. Certainly nothing starts with an A that's manual. So I've cleaned up the data just a little bit, pretty squeaky clean data coming in. Recapping what I've done, I changed the class column to vehicle type. This class is a reserved word, and then is automatic is holding a true if the transmission value started with an A. And false if it didn't. So conceivably, if your transmission was Fred Flintstone, just running really fast underneath the vehicle, it would say false. So this first example, and this example, I want to choose this because it should help with the clarity of what's going on. We might, of our categorical columns, manufacturer, model, transmission, FL, drivetrain, vehicle type is automatic. The two that we know are completely dependent on each other, just from domain knowledge, are manufacturer and model. Toyota does not make an Accord, right? Ford does not make a Dodge product or a Ram or something like that, right? So when I send in manufacturer and model, what I'm really doing here is sanity checking this whole chi-squared test. Because if Audi is the only manufacturer that makes A4 and Honda is the only outfit that does Accords, then we should have an exceedingly low p-value, right? So this p-value is 0. I'm not rounding anything here. This p-value is 0 because there is 0 evidence that supports the null hypothesis. Not even randomness will support finding the null hypothesis to be the case. That's how to read that one. Does that track that if one column is 100% dependent on the other, our p-value for a chi-squared would be 0? Cool, cool. You're only going to have 0 p-values in cases where there's just no evidence that supports rejecting the null. Or I'm sorry, when there's no evidence that supports the null at all. We were rejecting the heck out of the null for p-value 0. There's not even a chance of seeing extreme values if the null hypothesis is true, right? Cool. Now, what you can do with your cross tabulation, see how this whole lesson, I mean, we've spent a little while on this, but the whole punchline of chi-squared is get your crosstab with 2 categorical columns, then run your chi-squared, check your p-value. That's it, and just do this all day long. You can do this for every single categorical column, or if instead of doing this manually all day long, you wanted to do some automation, I'll walk you through that, subject to questions. I think I see something from Jules. Go ahead, Jules.
Just really quickly, if we wanted to do for example, something that was continuous, but turn it into a categorical variable so someone who was trying to do this was like trying to bin things,
Mhm.
you know, is that possible to I guess do that ahead of time to basically bin it instead and then put those two categories
Yeah,
together?
The question was, can we take a continuous number and bin it such that we have categories? The short answer is yes. The long answer is if the order of those bins is meaningful, we might want to find a test other than chi-squared that accounts for that order being meaningful. But if the bins don't necessarily have a lot of meaning, like high or low displacement or something like that, you make an arbitrary cutoff there. Yeah, you can totally make a binary or a category there. Yeah. Now, if those bins are, there's meaning to the order, I'm pretty sure there's a better test for that than chi-squared. Yep. Cool. Did that speak to your question, Jules?
Yes, thank you.
Yeah, we just have to do the binning. Yeah, I got a question about that a little earlier today as well. Cool. Let's do some automation. Hey, you're working with Python. Y'all are hip to automation. Let's do it. If I want to choose two categorical variables and get all possible combinations, what I'll do is read in my data, right? I've got the vehicle type, the is automatic, and then I'm going to specify out my categorical columns: manufacturer, model, drivetrain, FL. I can't remember what FL is. We can do the show doc and look that up. Vehicle type and is automatic here. So I've got all I have is a list of strings. And if we only need two lists of strings and we need all possible combinations, well, folks, you'll make a list using itertools. I imported itertools. And I said, hey, itertools, give me the combinations from categorical columns, but limit it to 2. So this gets me every single unique combination. Now remember, with combinations, order does not matter. It's just like when you order the combination noodle, it doesn't matter if the chicken went in before the pork. They're all in that noodle dish, right? Permutations, order matters, but combinations, order does not matter, right? Yeah, get the permutation noodle. Yeah, that's what. So what I mean by that is if we pulled up model manufacturer, that would be a duplicate. So we wouldn't get the duplicates. Its order doesn't matter. So even with a modest amount of columns, I don't know, 1, 2, 3, 4, 5, 6 columns, we get 1, 2, 3, 4, 5, 6, 7, I don't know, 12, 14 different combinations. And some of these might be, let's see, I left something out of here on purpose. I left out the transmission type right here because I accounted for transmission with that is automatic. I don't want to have the transmission and is automatic. They're talking about the same thing, right? So the chi-squared would say they are very related, right? Because one's a function of the other. Just like make and model. Model is a function of the make in reality. So to loop through this list of tuples, first thing you got to do before you do any hypothesis testing, set your alpha. I set my alpha too high, 0.05. And then I'm going to make an empty list for my outcomes and iterate for each combination in my list of combinations. I'm going to leave this code on the screen a while. We'll talk about it just a bit. What am I doing? I'm building out a list of dictionaries such that each combination of column names is one of these outcome dictionaries that I ultimately append to my list. And folks, when you have a list of dictionaries, you can turn that into a data frame if all the keys are the same. If all the keys are not the same, you just get a bunch of nulls, and you shouldn't be putting them in one data type together. So what I'm doing is saying, hey Python, give me an empty dictionary. Then make a new key called column 1. And because the tuple respects and is bound by the same index laws, the 0 index as a list or any other kind of collection, that's my first combination. So the first time through this loop, we're combining manufacturer and model. That's the first test through this loop. So combination bracket 0 is manufacturer because that's of the tuple, that's the first element. Second element is model. The last time through the loop, our pairs are vehicle type and is automatic. So on that dictionary, I set up the column name. My keys are not very original. My key is called column 1, column 2. And then the value will be whatever the column's name is. You'll notice I'm going to calculate my observed. So calculate my actuals with a crosstab. And I'm programmatically reaching into that string. If reaching into this tuple is kind of throwing you for a loop, you could make a variable to hold combination 0 and make a second variable to hold combination 1, but they're pointing to each pair respectively, right? I'm going to do my cross tabulation, and that is the secret sauce to be able to call the stats module or SciPy stats modules chi-squared contingency. And that's going to give us back chi-squared, p-value, degrees of freedom, and expected values. Guess what we cared about? That p-value. And if the p is lower than alpha, our alpha is 0.05, then we'll say, I'm going to make a new column that says reject null true. And then if p is not greater than alpha or is not less than alpha, then we fail to reject the null. That's saying there's no evidence to support rejecting the null. So let's run that and let's take a look at what we get. We have a lot of trues going on here. Let's think about these. Now the column 1, what that first pairing, manufacturer and model, we already know from our manual experiment that the p-value is 0. These are completely dependent on each other. We can't reject. We reject the heck out of the null hypothesis, right? Because model is a function of manufacturer. What about these other patterns? Well, drivetrain and manufacturer, that p-value is significantly low. Why is this? Well, Jeep doesn't make any 2-seaters, right? Dodge doesn't make any 2-seaters. I guess they do. They make a Viper. I don't think there's a Viper on here. But there's reasons why these p-values are so dang low. It's because there's not enough evidence in the data set or there is enough evidence in the data set to reject the heck out of that null hypothesis. Right? So as we go through here, the only places where we reject the null hypothesis is when the p value of that pair is higher than alpha. And this should make sense. Is the drivetrain independent of automatic? It seems to be. We don't have enough evidence to reject the hypothesis, the null hypothesis that they are independent. Okay, so we can move forward with the understanding that they are independent. We have automatic rear wheel, automatic four-wheel, automatic front wheel, etc. Okay, so that's kind of cool. That's kind of cool. I mean, look at that, 164. So 9 times 10 to the negative 164th power. So vehicle type and model are related. We do reject the null, but they are not related, but that they are independent of each other. Andrew?
Yeah, is there a reason why you did year? I consider year as a category.
Yeah, I think you could. I think you totally could here because somebody could make an argument that same vehicle, different years, there's some extra dependence there, but you could totally use year in here. Same thing with the displacement.
Yeah.
I had a thought around the displacement and the cylinders as well, although these are tightly linked. Usually displacement is a function of the number of cylinders or how big those cylinders are. I would feel comfortable using year in here. Yeah. And if your displacement values weren't all over the place, if you had like 10 or less. I'm just pulling that number out of a hat.
Yeah, that,
But yeah.
could include numbers as categories. And that's-
Yeah, and in a lot of ways, especially with vehicles, the years are feel more like a category.
Right.
Yeah. Except to the poor salesman who wants you to buy next year's model, right? Yeah, I'd feel comfortable with that. Yeah. And if the displacements were kind of only a set of, a small set, I'd feel comfortable with that too. Same with cylinders.
So I did the displacements, that was actually the one I chose.
Yeah,
So I just. I figured there was a relation between, I did manufacturer and displacement.
yeah.
Because, you know,
Some manufacturers make big honking engines.
so Hyundai, as long as like they have an average displacement as high as something like your Lamborghini or Mercedes, right?
Yeah.
So, and it was actually, there was actually a relationship.
Yeah, that makes sense. And the reason why it's okay to use these kind of discrete numbers here is because of that cross tabulation. We're counting up number of 1999 models, counting up number of 2008 models. That's why I feel comfortable working with that. Same thing with the bins. If you bin to the continuous, so you did like small, like good, bad, and ugly highway mileage or something like that, right?
Average value was 2.1 to negative 70.
Hey, they're pretty related.
Yeah.
Yeah. Cool. All right. Any other questions about, I'm scrolling around. Let me stop scrolling, show you the code. Any questions about the mechanics of the code here? Floor is open. Okie dokie. Oh,
I have a
Arsene.
question.
Yeah, go ahead, Arsene. What you got?
This looks great.
Oh, shucks, thanks.
It really does. I thought about how I could put all of these together, but it seemed so difficult that I discarded the idea almost immediately. And the question that I have about it is, so you designed outcomes as a list, and then
Oh, outcomes plural as an empty list, yeah.
and then outcome as a dictionary.
Correct, as a singular. This is a,
Got
if you're
it.
asking about the variable name, this is a habit of mine. If I'm looping, if I'm building up a list, like notice categorical columns. I know this is a list. I know there's a couple of things, so I make it plural in my variable name, as opposed to just calling it X.
It totally makes sense, because when I started reading, I realized that outcome was singular and not
Yeah.
plural. Because I was wondering how you were able to make up the data frame with two variables that are the same, but that are pointing to two different things. But I didn't realize that outcome was plural and then singular. That's all.
Yeah,
Thanks.
these don't have to be the plural version of the singular.
Yeah.
They don't have to be. You could just use X, but X doesn't add meaning or value, right? You'll notice I peeled apart my combinations by doing for singular and plural.
Yep.
And this outcome, I could just say, this could also be called result. That would be a fine. Yeah. Because it's the result of one test. And I have the column name, the two column names coming in, the p-value, and if we reject that null or not.
Thanks.
Yeah, this pattern of building up an empty, starting with an empty list and building it up, you'll probably started noticing that the 101 exercises in the pre-work kind of edged you and nudged you in that direction. That's on purpose. It's because if you can produce a list of dictionaries, or I mean, even something with this many moving pieces, you've got yourself a happy little data frame. Right? This is more complex than those 101 exercises, but if you can get the inner code of the loop to run on just one pair, then you can take it and jam it in a for loop. Right? And this is a case for knowing your Python above and beyond just pandas, right? There's a lot of folks who've done a lot of tutorials who say they know Python and pandas when really they just know pandas. But they play together, right? They play together. All right, y'all want to talk about the last two? And did I speak to your question, Arsene? Any follow-up there? Okay, cool. All right.
Thanks.
Yeah, you're welcome. All right, exercise 3, we're talking to a database. So what did I do? My team members may have already copied over their env file from their work, but that does, because the envs get ignored, I have to copy mine. So I opened up my terminal and I did something along the lines of, if I'm in the statistics folder, I said copy, go up a directory, go into the DS libraries, copy env.py here. I'll make that a little larger.
Well, online, we actually can't see your screen.
Oh, let me fix that. Thank you for saying something. I'm saying, hey, operating system, go up a directory, go into my DS libraries, copy env. Here is what that period means. Okay. I also did go up a directory, go into DS libraries, grab git ignore, and copy it here too. Right? Try to get both of those at the same time. And what that's able to do for me, I'm importing git db URL. I decided to put this in the env. Now, how did I create the SQL here? What I did was I opened up SQL, the SQL client, and just tested out my joins and my to date and made sure everything was sane before I copied the SQL code. Right? I'm only selecting gender and department name because those are the only 2 columns that I need. If you selected star, you'd still get a lot of data, but your cross tabulation is still only focusing on those 2 columns, right? So I'm saying, hey, select gender and department name from employees, join dep/demp, join departments, and make sure that they're current. And that gives me a happy little data frame of, I don't know, 240 something thousand people. And so we have their gender, and we can take a look at the distribution if we need. We have the department name. I think there's 9 departments. And so when we do our cross tabulation of gender and department, we can look at the percentages by gender for each department. And this is a really interesting example of where, so we're looking at observed data, right? When we talked about, I know in the lesson I said, don't worry too much about the internals of like how to build a chi-squared from scratch. But if we were to say df.gender.value counts, the proportion between genders population-wide is informing, underneath the hood is informing that chi-squared, right? So this is kind of interesting when we see it looks like across the board there are more men than women in a lot of these departments, but some of them the disparity is larger, right? So let's take a look. Let's actually run our chi-squared contingency and check our p-value. So we failed to reject the null. So let's check the p-value. Wow, that p-value is really, really high. So how to read this is we don't have sufficient evidence to reject the null hypothesis. So if we don't reject it, we move forward with the understanding that is arguably the case, right? Lincoln?
Like first time I started like that, and I realized that we're only looking at sales and
Oh, did I do only half the problem? Oh, only in sales and marketing. Oh, okay, cool. I totally did half the problem.
Oh, yes, I was.
Excuse me, that was unintentional. Yeah, so we've got customer service. Actually, we can whittle this down. It's up to you if you want to do your whittling in SQL, if you want to do your whittling down in Python. We can tack onto this. We can say and depth name is in some set of results, and we'll say sales and marketing. Okay, and then if we check the department name, we got a lot of sales and a lot of marketing. And then we have department name, but only 2 of those values. Thank you for keeping me on target.
Because I was so lost with this question, and then I figured it out. and-
Yes, yes, okay. Much better, much better. Okay. So in both of these, let's take a look at that p-value, or I have to recalculate that p-value actually. We still fail to reject the null. The p-value did change. If we were to, yeah, this is great. This is a nice high p-value. We fail to reject the null. There's not enough evidence to support rejecting the null, which means there's no evidence to support moving forward with the alternative hypothesis. So the null is the best we got on this so far, without further tests and or investigation. Cool. Exercise 3, part 2. Our null hypothesis is always that there's no, my findings, null hypothesis, there's no relationship. We have insufficient evidence to reject the null. So the evidence supports the claim that gender and department are in fact independent. So exercise 2 is an employee's gender independent of whether or not they have been a manager. I mean, HR might want to know this. Also, you know, if the company's being sued, the attorneys might want to know this too, right? So I'm going to select gender and title. And in this one, because part of this question, whether or not they are or have been a manager, I'm keeping historic data here, which I also like because there's only 9 departments, and a chi-squared with an observation of 9 is weird. You probably don't want to put your weight on it too much. Also, I made a manager title. So we have every title, but I'm going to turn this into a binary by saying is manager, and that's going to hold a nice happy little binary. Okay, so I could effectively ignore the title from here on out. I've got is manager, I've got the gender here. I'll do my cross tabulation. And you guessed it, if you got the cross tabulation, you send that into the stats chi-squared contingency, grab the p-value. And yeah, unless you have an unsanitary alpha, we are going to fail to reject the null hypothesis. So if we say if p is less than alpha, okay, so if we fail to reject the null hypothesis, another way of thinking about that is we don't have sufficient evidence to reject the null hypothesis. Another way of saying that is we move forward with the understanding that gender and being a manager at this company, they do seem to be independent. They do seem to be independent because we can't refute that claim. Marketing might, you know, the outbound marketing might want to say, those are totally 100% independent. From a statistics side, that's not what we're saying. We're saying we don't have evidence to reject that claim. Fred? Absolutely.
On that SQL section.
Mhm.
Aren't we like doubling our employee number? So we're gonna have employee number multiple times for all the titles and therefore have a different count, right?
Yeah, we will have multiple, if somebody has multiple titles in their history, they will show up multiple times here, yeah. Is that gonna be enough to skew the data? Probably not. We could check.
It doesn't. I was just, so you wouldn't mind doing that, I guess, is my question.
No, because each observation here is not one individual at one time, it's one individual at one job title. And if we had employee number in here, we might see employee number duplicated. But I think this helps speak to the question of if they are or have ever been a manager, yeah.
That's like, I just changed it, so I actually.
Yeah.
It's distinct.
Mhm.
Employee number, and it added like 6 people to the whole map, so.
Okay, so in case you didn't hear that on the call, Greg ran with distinct. And it got back 6 different.
Yeah, like I first I just realized that all the slides put out distinct. And it added 1 female, like 5 or 6. So overall.
Yeah, if this was a much bigger problem, this might necessitate a more sophisticated statistical test than chi-squared, right? Yeah, Kate, go ahead.
Just to clarify, 6 different in total number of employees, because I was off in the order of 100,000 for employees. So I joined employees to the manager table, not to the other table.
Oh, okay.
But you still get 24 total managers, but I have literally half as many that weren't managers. And that's where I thought it would be a significant difference in whether or not we should use that. Does that make sense?
I think it does, yeah. I'd feel comfortable using that. It's peculiar here because chi-squared is generally we think of each observation as completely independent of each observation. When I say independent, I mean like we're usually thinking of as different individuals. I think if we were in a stats class, we could really jam on this a while and talk about what an observation is. Here being a period in time versus ever. In practice, in reality, stakeholder needs an answer by noon. Yeah, it's not going to matter.
Say like mine is probably similar to yours. The only difference in result between yours and mine is 0.1%.
0.1%.
I just ran it again. I set mine to do the same way you did.
Yeah.
And the difference is actually 2. It added 1 to male and 1.
And another piece of challenge here is that we only have 24 managers historically. I think that is more of something that makes a chi-squared smell funny to me than having like less than 30. They really start to break down less than 20. Like I wouldn't trust a chi-squared where one of the observations is less than 20. It's not the right call.
So
Yeah.
what's an alternative?
To go get a PhD in statistics? That's my way of saying, that's a great question, Jules, and I wouldn't know the test off the top of my head in this case, where we had to like force each row to be an individual. We could also kind of collapse our duplicates. That would be some fancy Python, some fancy pandas group by with a custom group by function. I'm not going to chase that rabbit right now, but like conceptually, this is just the tip of the iceberg of statistical tests, right? Chi-squared, t-test, and correlation. It's not the exhaustive accounting of everything, of every possible statistical test. Yeah. Is that acceptable for you, Jules?
No, it is. I mean, you just said it kind of breaks down at 20 and we're at 24. So I was just curious if there was something else we should have used instead of
I
that.
see what you mean. I see what you mean. Not the part where we've got duplicate individuals, but the part where you've got 24 observations. Yeah.
Yeah.
you really can't make a lot of statistical conclusions about when you have so few observations. The magic, yeah, like, I think t-test, its magic number is above 20, it's like 25, something like that. And chi-squared really starts deteriorating, especially when we're talking thousands and thousands and thousands compared to like 24. And I wouldn't even run a t-test. I wouldn't even bring statistics to the party if you only have 9 of something. You just read it and guess. Yeah, like the PhD in statistics, like, we'll tell you, oh, you have 9 observations? Guess. Yeah. You need more data than that. Yeah. Yeah, yeah, I'm glad we got to the bottom of that. Cool. So I do fail to reject that null hypothesis that gender and management at this company are independent. That's good news for equity, right? And there you have it, folks. There you have it. Let's stop the recording and open up for any other questions.